So, let's talk about test-driven development. You know the basic red-green refactor cycle, right?
Sure thing. Write a test, watch it fail, make it pass, then clean up. Kinda like how I tackle my to-do list, but with more code involved.
Exactly. And the key here is that each step has a specific purpose. The red phase is all about identifying what you need to do next.
Like figuring out what the next feature should be. That's usually the hard part for me.
No. It's about writing a failing test case first. You're defining the behavior you want your code to have before you write any production code.
Oh, gotcha. So you're setting clear expectations from the get-go.
Precisely. And once you've written the failing test, red, you move on to making it pass by writing just enough code to satisfy that test, green.
But isn't there a risk of writing too much code at this point? I mean, over-engineering can happen pretty easily.
Absolutely. Which is why you must resist the urge to add functionality beyond what's necessary to pass the current test. Minimalism is key in this phase.
Makes sense. Then comes refactoring, where we clean things up without breaking anything, right?
Yes, exactly. After getting green lights, refactor your code to improve its structure and readability, while ensuring all tests still pass.
Sounds like a lot of back and forth between testing and coding. Could get tedious quickly.
True, but it ensures that every bit of code serves a purpose and maintains quality throughout development. Plus, it helps catch bugs early on, rather than having them pile up later when they become harder to track down.
Guess that makes sense for larger projects or teams where everyone needs to keep an eye on everything else happening around them.
Definitely. Especially when working with complex systems or large teams. TDD keeps everyone aligned and reduces integration issues significantly. Absolutely. Speaking of maintaining quality, let's touch on another aspect: choosing between unit testing and integration testing within TDD.
Sure. That's always been a bit confusing for me. When do you lean towards one over the other?
Good question. Unit tests are great for isolating individual components or functions to ensure they work as expected independently.
So it's like making sure each piece works perfectly before putting them together?
Exactly. They're faster to run and easier to maintain because they focus on small units of code. On the other hand, integration tests check how different parts of your system interact with each other.
Got it. So integration tests are more about seeing if everything plays nicely together?
Precisely. Integration tests help catch issues that might not be apparent in isolated unit tests, especially when dealing with external dependencies like databases or APIs.
Makes sense. But doesn't doing both take a lot of time and effort?
It does require some extra effort, but combining both approaches gives you comprehensive coverage. Unit tests give you quick feedback on smaller pieces, while integration tests ensure those pieces fit well together.
Sounds like finding the right balance is key then.
Indeed. The goal is to strike a balance where you have enough unit tests to cover most scenarios quickly, and targeted integration tests to verify critical interactions.
I guess it's all about knowing what to prioritize based on the project's needs and complexity.
Exactly. And remember, TDD isn't just about writing tests. It's also about designing better software by forcing you to think through each component carefully from the start. Right. So let's talk about effective strategies for writing failing tests first. This is a crucial step in TDD.
Yeah, it feels a bit counterintuitive at first. How do you ensure you're doing it right?
Well, the idea is to write the simplest possible test that fails because the desired functionality isn't implemented yet.
So it's like setting up a clear target that you know will fail initially?
Exactly. Start with the bare minimum, a simple assertion that checks something obvious. For example, if you're implementing a function to add two numbers, your initial test might just check if adding 0 returns 0.
That makes sense. Starting small and simple seems easier to manage.
Definitely. The key is to make sure the test fails due to lack of implementation, rather than any other reason. This way, when you implement the code, you'll see a clear transition from red to green.
Got it. It's almost like scaffolding, building up incrementally instead of trying to tackle everything at once.
Precisely. By starting with a failing test, you establish a clear baseline and can measure progress as you go along. This helps keep the development process focused and iterative.
Makes sense. It's like having a checklist for each step of the way.
Exactly. Each passing test acts as confirmation that you've completed a specific task correctly, leading to more robust and reliable code overall. Absolutely. Now, let's talk about balancing test coverage with development speed. It's a common challenge in TDD.
Yeah. I've definitely felt the pressure to move fast while still writing good tests. Any tips?
One key is to focus on high-value areas first. Prioritize writing tests for critical functionalities and core logic.
So it's like picking your battles wisely.
Exactly. Don't waste time over-testing trivial components. Focus on what really matters and can break the system if it fails.
Makes sense. But how do you decide what's worth the extra testing effort?
Identify the parts of your code that handle important business logic or have significant impact on user experience. Also, consider modules that interact with external systems or databases.
Got it. So it's about weighing the potential risks and impacts.
Precisely. Another strategy is to use a mix of automated and manual testing where appropriate. Automated tests are great for repetitive tasks, but sometimes manual checks can be quicker and just as effective.
That sounds like a practical approach, finding that sweet spot between thoroughness and efficiency.
Exactly. The goal is to achieve sufficient coverage without slowing down development unnecessarily. Continuous feedback from tests helps ensure quality, while keeping the pace manageable.